I think. Okay, moving on to something called the difference quotient. And this is half of chapter 2 anyway. So if I do it now or later, it's the same thing. So let's talk about difference quotient. This is an extremely important concept. Stop me if you have questions. This is, as I said, half of this course, pretty much, not just chapter 2. Okay, what does it mean, first of all? Okay, so let's take a look. Let's look at a function. Here's function f of x. You're going to see this graph several times this semester. Any graph. So here's the function f of x. We have a point. I'm going to call this point P. It has 2 coordinates. It has to have x and y, otherwise I can't plot it. And it's on the graph. And if x, the x coordinate of P is x, what will be the y coordinate of P? Let's say Lindsay.
It should be y.
Correct. How do we write y in a different way? Excellent. Thank you very much. So the coordinates of P are x comma f of x. Okay, now we're going to create a point Q. And point Q is very, very close to P. But I'm zooming in so I can explain. I'm giving you the x coordinate of Q, which is x plus a little bit. H is a little bit. 0.1, 0.5, 0.3, 0.005, something tiny. So now I also want the x coordinate, the y coordinate of Q. Can anyone give us the y coordinate of Q? Josh?
I don't know.
But look how we determine the y coordinate for x. How do you think we're going to determine the y coordinate for Q?
That would be f of x plus h.
F of x plus h, indeed. So then Q has coordinates x plus h, comma, f of x plus h. So I know you didn't say that, but I want to clarify. When we plug in x, so I have f of x. When x equals x plus h, then we get f of x plus h, not f of x plus h. So be very careful. I know you didn't say that, but I just want to emphasize. So if a function f of x, if I want to evaluate it for 2, I find f of 2. If I want to evaluate it for x plus h, I shouldn't write that, so I should write just an arrow. So if x gets replaced by x plus h, I don't get f of x and outside plus h. No, x gets replaced by x plus h inside the function, not this. Okay, so at this point, I'm going to draw a line between, it crosses the function in 2 points, point P and Q. This has nothing to do with trigonometry. It's called a secant line because it crosses the graph in 2 points. 2 points. There is also something called tangent. Nothing to do with trig. I'll come back to my graph in a moment. So if this is the function, here, this is a tangent. So tangent line. It does not cross the graph. It only has one common point with the graph. So this is the tangent line. This is the secant line passing through 2 points. All we want to determine right now is the slope of the secant line PQ. That is the difference quotient. We will write the meaning of it in a moment, but just let's determine. Can anyone give us the slope of the secant line? Can anyone dictate? Let's say Mickey.
What?
The slope of line PQ.
It would be y2 minus y1.
Correct. What is y2? Excellent. What is y2?
Y2 would be q.
Q is a point.
F of x plus h.
Excellent. F of x plus h minus
x. F of x.
excellent over
X plus h.
minus.
X.
Great job. Brilliant. Thank you. These two go away. So f of x plus h minus f of x divided by h, to remember forever. To remember forever. The difference quotient. And now let's see what it means. So let's come back to the graph for a moment. So let's suppose that these two are 2 points not close to each other. There is a distance between them. So what does the slope of this line represent? It's called the average rate of change. So this will be the average rate of change. The slope of this line, I'm going to write it down for you. The slope of this line will be the average rate of change between P and Q. I'll come back to the difference quotient. So in general, the slope of PQ is the average rate of change of f of x between P and Q. Measurement unit for the rate of change is a ratio of measurement units. So if the function is a distance and x is time, then the average rate is measured in miles per hour. So it's a ratio of two measurement units. The measurement unit of the function over the measurement unit of the x variable. So if the function is distance, let's say in miles, and the x is time in hours, the average rate of change has a measurement unit that is a ratio. Okay, so this is in general. Now, what does this mean? Pretty much the same. So the difference quotient, because the 2 points are very close to each other, the difference quotient will be almost, not exactly, almost the instantaneous rate of change at P. Still the average rate of change between P and Q. But because Q is so close to P, that means that the difference quotient is almost the instantaneous rate of change at P. Not exactly. So I'm going to write this down on page 8. Difference quotient, almost. I'm going to put in parentheses, not exactly. So you remember that. Almost the instantaneous rate of change at P. So now we can determine, where is my, here it is. This is what this is, a rate of change for the function 1 over x. The difference quotient for function 1 over x squared. So for f of x equals 1 over x squared, find and simplify the difference quotient. We're not going back. We need to remember the difference quotient by heart. Like everything else I said, whatever I say, remember, 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 we have to remember all those. So remember, 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 remember. Also, the piecewise defined function. Okay, the same thing here for the difference quotient. We have to remember this. Where is my difference quotient? This one. Okay, good. So the difference quotient, I will write it this time, f of x plus h minus f of x divided by h. So again, this is the almost the instantaneous rate of change at a point. And you will see what that means later, what it will give us. Okay, can anyone dictate? I'll do the easy part and you do the difficult part. 10, are you there? Can you tell us how to write it?
Do you want me to like just give you the numerator after
Yes.
distributing the
Yep.
x and h? All right.
No,
So
no, don't distribute anything for everyone to see what we're doing the first step. Just the very first step.
Oh, okay. So it'd be 1 over x plus h squared
Very good.
minus 1 over x squared.
That's it. Do we all understand this?
Yes.
Any questions? So before I continue simplifying, I just want to make super clear that when we have a function like x squared plus 3x minus 4, if I'm asked to find f of x plus h, how will you replace? How will you determine f of x plus h?
We change the x with x plus h.
Correct. So be very careful. We have to write this step first. Okay, I'll come back. I didn't forget what I'm doing, but can anyone refresh our memory? What do we get with x plus h squared?
X squared plus 2xh plus h squared.
Thank you. Plus 3x plus 3h minus 4. Great. Okay, so then now we're coming back here. Okay. Can anyone give us the least common denominator in the numerator?
X squared x plus h squared.
Awesome. Do we all agree with that? Who said it?
Me, RJ.
RJ, very good. Thank you. Any questions? So this denominator was multiplied by x squared. So what do I need to multiply the numerator by?
X squared.
Great. This denominator was multiplied by x plus h squared. What do I need to multiply the top by?
The same thing, x plus h squared.
That's it. That's correct answer. By the same thing. You cannot multiply the denominator by something and not multiply the numerator by something. The same thing. Okay. So next step, what do we have in the numerator?
Plus 2hx plus h squared.
Minus.
Oh, that's minus.
You're correct, but we have to distribute that minus first. Before I continue, another super important to remember. Note, when finding, simplifying the difference quotient, two things must happen. If they don't, something is terribly wrong. One, all terms without h must simplify in the numerator. If that doesn't happen, you know you have a mistake. Start from scratch. Number two, h from the denominator must simplify at the end when we are ready to simplify it completely. So if these two things do not happen every time you find the difference quotient for any function, something is terribly wrong. And this is the correct order also. All terms without h must go away, and after that, at the very end, h in the denominator must go away. Another note, there is still h left in the problem. Note, but not h in the denominator. Some term or terms may have left h somewhere. So h does not completely go away. H from the denominator must go away. Okay. So now I'm back. I will just copy it from that stage because I don't want to go back to that page. So we have x squared minus x plus h squared, everything divided by x squared, x plus h squared divided by h. So h is the same with h over 1. So in the next step, I'm going to flip because that's how we divide fractions. Here's another refresher for you. A divided by B, everything divided by C over D is A over B times D over C. This is how we divide fractions. So I will copy x squared, x plus h squared. The fraction from the top gets copied. But then I have to multiply by 1 over h. So now you already told me x squared minus, but careful because we have to distribute -1, minus x squared minus 2xh and minus h squared. Do we understand where all these are coming from? I'm listening, but I don't hear anything.
It's just expanded, right?
Correct. And distributing -1 to all three terms. We had an example a minute ago in which we squared x plus h from the first class. I don't want to go back to that. I hope we can move on from here. X plus h squared is x squared plus 2xh plus h squared. And that's exactly what we had in this problem, but we had to distribute -1. So all terms without h from the numerator must simplify or cancel. Yeah, they are canceling. X squared minus x squared. All terms without h are gone. Now at the top, I have to factor out. What am I factoring out at the top?
H.
Yes, but minus. And because of that, the h that I talked about from the very beginning, the one that was in the difference quotient in the denominator, that one must go away. So that's why it goes away, because all terms without h are gone, and you can factor out an h and simplify the h in the denominator. Okay, what do we have in parentheses? Gabriel.
It's 2x, 2x and then just h, minus h. Oh no, plus h.
Excellent. Can anyone give us the final simplified form of the difference quotient for this function? Javon? I couldn't hear you.
I'm not sure.
So first of all, you have to copy the minus in front. Then the numerator is 2x plus h, because there is nothing else. And the denominator has to stay as is. Do not, note, do not expand the factors in the denominator. They have to stay as is. Do not waste your time on the denominator. It has to be factored and it has to stay as is. Do not expand factors in the denominator. Ever. Questions?
Why is that the case that you wouldn't expand the exponent?
We work very hard to have every denominator factored so we can simplify if we can. If it's expanded, I can never do anything. All denominators have to stay factored and as products, not as a sum or difference.